Welcome everybody to a brand new day of Computer Science 41. It is week 8, day 1, and we're going to be talking about 2D vectors today. If you want to hold data in a grid, like a color grid, like you did on your Bridges assignment, then in C++, the standard library, there is no two-dimensional data structure, which is kind of a weakness in the standard library. There's a couple different ways you could hold data. Like imagine you're going to do like tic-tac-toe, right? If you're going to do tic-tac-toe, you've got like a 3x3 grid of like characters, I guess. So if we wanted to do tic-tac-toe, we could do something like this. We could do like a character array, and we can call this like the board 3x3. So this is the C way of doing a 3x3 grid. It's not good. As with all things with arrays, they look simple, they're easy to type, but you start running into issues like when you start passing them to a function. Like if you have a function, like, I don't know, int2 takes a char board 3x3, like that. Let's have it just, I don't know, return board 1, 2, like that. That's fine. Foo board, right? That's fine, except it's got a fixed size, right? It's a fixed 3x3 size. If you want it to work with boards of any size, you can't. It just, if you have something like this, that's fine. You can have the number of rows unspecified, but if you try to have the number of columns unspecified, it doesn't compile. And if you do something like this, like that's, yeah. So arrays look simple. They're simple to write. They're hard. I don't know if hard's the right word, but they're annoying to use. Okay, so we are just going to pretend that we have never heard of arrays in this class, and we will not use them. Okay, so option -1, use a 2D array. Okay, and we're calling that option -1 because it is not a real option. So option 1 is use a 1D vector and pretend it is 2D. So we can make a vector of chars or chars if you are a care bearer. And how many if we're going to make a vector to hold all of these spots in a tic-tac-toe grid, how many spots are there total on a tic-tac-toe grid? What number do I need in here? You guys know what tic-tac-toe is? Yeah, we need 9 spots, right? 9 characters that'll either hold a blank, an X, or an O. So we need to put inside of here 9. Okay. And we can pretend it's 2D, right? So if we have like, you know, const rows equals 3, columns equals 3. If we want to like grab the center spot, like let's set the center spot to be X, we could do it like this, vector dot at. Here, let's do this. Int row equals read. Please enter the row to put an X on. And we can go to column 2 if we want. Please enter the column to put an X on. And then we could say vector dot at row times columns plus col, like that. And we can do algebra. This is actually how we typically write code in like high performance computing world. We just make a 1D vector and pretend it's 2D using a little bit of algebra like this. Let me explain this algebra in case this isn't clear to you. So what we're doing is we have a 1D vector. It's holding 9 characters, right? But we're going to pretend that it is a tic-tac-toe grid, right? And so the tic-tac-toe grid is going to be index 0, index 1, index 2, index 3, index 4, index 5, 6, 7, 8. So even though in reality it is a 1D vector like this, too many. even though in reality it's a 1D vector, we're going to kind of pretend it's a 2D vector. And so we're going to be given a row, which is this way, row 0, row 1, row 2. And we've got columns which go this way, column 1, 0, column 1, column 2. And so if you look at this, there's an algebraic relationship you can figure out, right? So if I give you a row and I give you a column, you can work out the algebra for this. So every time you go 1 to the right in the column, the index goes 1 to the right. Every time you go 1 down in the row, you go up by the number of columns there are. There's 3 columns. So every time you go down a row, it's like going right 3 columns. So if you were at index 3 and you wanted to know what spot in the array was below index 3, that would be index 6, right? And that's because there are 3 columns. And so you go 1, 2, 3 to the right, and that's like going down 1. Does this make sense to you guys? The algebraic equation is row times columns, how many columns there are, plus the column number. It's a little bit of algebra. And this is actually how we do it in practice in the high-performance computing world. We typically just pass a single vector or array around like this, and we just use a little bit of algebra to figure out, okay, well, this guy is here, or whatever. So the guy below me is 5, right? The guy above me, there is nobody above me because it's below -1. It's -1, it's below 0. So that's kind of the pro user way of doing it. And the benefit of this is speed, okay? The reason why it's fast is because computers are designed to work around contiguous blocks of memory. Every time you're doing something where you're like reading from an array, like you're like reading temperature data and working with it, you very traditionally just start at 0 and you just go to the right. You just work your way down the array. Computers are sort of optimized around this thing. And so as you're like loading data, the computer's actually prefetching data from RAM into the CPU ahead of you. And so when you have a nice contiguous block of memory like this, you get what are called cache hits. And it's actually like maybe like an order of magnitude faster. And so do we care about speed in this class? Do we care about do we care about speed in C-Sci 40? A little bit, not really though. Like maybe with call by reference, what's the difference between passing in, like if we were to pass in like vector of int and vec like that. Like what if we passed in, this call by reference or call by value? Like if you do call by value, duplicates the entire. Maybe care a little bit, maybe, but no, mostly not. So the reason why I teach this to you is because it is good practice. Okay, it's actually a really good habit to get into, to always pass vectors and strings by reference. Unless you explicitly want to make a duplicate of it, you should just get into the habit of always passing by reference so you don't duplicate data by accident. Okay. Don't do things that are stupidly, woefully slow, but don't agonize over efficiency is a great way of putting it. Yeah. And so what we have here is code that, like I'm comfortable with this code. I'm fine with it, but there's probably a better way. And there is. So let me show you. Well, maybe better is not the right word, but like an easier way. So this is the way that I recommend that you do it in option 2. Easier, a little harder to declare, but easier to use, which is something called a 2D vector, which is a misnomer because vector by definition is a one-dimensional set of numbers or whatever. Like vector literally means it is a 1D data structure. It holds a one-dimensional bunch of integers or characters or whatever. So we're going to do a 2D vector here. And it looks like this. Vector of vectors of chars. Named vec. And let's call it vec2. And it will be of size rows by a vector of chars of size columns, like that. And this will make a 3 by 3 vector. Okay. The memory is not contiguous. What this actually does is it declares rows is 3. It is 3 times going to make a vector. And the first row is going to be a chunk of memory. The second one's a chunk of memory that's contiguous. The third one's a chunk of memory that's contiguous. Are they next to each other in memory? Probably not. Maybe, but probably not. You have no guarantee of that. And so this is actually making 3 vectors of size 3. And so why, like this doesn't look easy to use, right? This looks kind of chonky and kind of ridiculous, you know? Like this is a vector of chars and... But let me show you how this looks, okay? So let me show you how you actually use it. So if I wanted to set row, 3, column, or, well, we only have 3 rows, so if I wanted to set vec2.at, if I wanted to set row 2, column 1 to be x, I could do it like that. See how nice that is? So I can say at row 2, at column 1, set it to be x. I don't have to use algebra, right? It's kind of doing the algebra for me, all right? And if you want to be unsafe, this will do bounds checking, right? If you want to be unsafe, you can say vector2, square bracket 2, square bracket 1. This is unsafe. So that is, if you do that and you go out of bounds, it will very silently corrupt memory and just write to whatever is in RAM there. And you're like, why is my code crashing? Weird. So for this class, this is how you should do it. Okay. So everybody on chat, please show me how to make a tic-tac-toe. Give me 3 lines of code that will result in 3 X's in a row or 3 O's in a row if you're an O player. And while you guys are doing that, I will show you how to print a 2D vector to the screen. So I guess I'll be using option 2. So 2D vectors or 2D arrays, 2D data structures require doubly nested for loops. If you have a 3-dimensional data structure, you need a triply nested for loop in general. You could feasibly do it with 1 for loop if you are, doing the algebra on it. But typically speaking, that is a copy paste error. Always there. Okay, always double check for copy paste errors. Okay. So for every row, for every column, print out the value at that row. So cout, we'll just use option 2, I guess, but vector2 dot at I dot at j. Okay. And then at the end of the row, we will cout. Okay. So give me some code that I can copy and paste in here that will give me a tic-tac-toe. So use your traditional for loop like this. Or you can use a ranged for loop. And we can do something like this for const vector chars named row. So for every row in the vector, for every character in the row, and that needs to be by reference, vector2, sorry. So for every row, for every column, so character scout that value. All right. So we got on here dot at 2, dot at 1, dot at 2, dot at 2, dot at 2, dot at 3. That is out of bounds, Brandis. If you have 3 rows, the numbers go from 0 to 2, not from 1 to 3. So Fernando, same problem. You guys are both, you are out of bounds. So the numbers go from 0 to 2. Starts at 0, goes to 2. Yeah. In computer science, we always start counting from 0 instead of 2. So if I compile this code, run it, no return statement. Yeah, we don't need you. Row 3, 4 out of bounds. Right. 3, 3 out of bounds. 1, 1. Okay. We're using vector 2. So let's just comment this out. All right. Dot at row. Dot at column. So it's always rows first, then columns by convention. Okay. So what we're going to do here is we are going to read a row and a column in, and we'll not do that, and we will set the value to here, and then print it out. If vec2.at_i.at_j equals 0, which is what characters get initialized to, then we will scout a dot or something like that. There we go. Should have done that for this one too. So you can see the traditional for loop, range-based for loop, giving us the same result here. Okay. So nobody has the tic-tac-toe for me? Give me some code. Give me some code to do tic-tac-toe. So Brandis and Fernando were close, but they went out of bounds. All right. So let's comment this revision out here. Either ways. So that'll print out our board for tic-tac-toe. There you go. Yeah. vec2.at2.at0. Yeah. All right, cool. That looks good. All right. So I guess I'll just rename vector 2 to be vec. Search for vec2. CW vec. N to go to next. Dot to replace. N to go to next. Dot to replace. N to go to next. Dot to replace. And dot to replace. Okay. CW changes a word, and then dot will repeat the last command you did. And then when you search for something with front slash, like if I search for a vector, I can hit N, and flip through all the things. Shift N searches backwards, lowercase n searches forwards. And so you can use that to quickly search and replace inside of Vim. There is actually a search and replace command that I never use because I've had way too many cases of it accidentally, changing. Like you change the word, vec2 to vec, and then you don't realize that you have another function that uses vec2, and that's broken now. So I like to look at every change that I make before I search and replace it. All right, so we've got here. Yeah, that's good. And then we could probably put this into a for loop, right? And maybe switch players from X to O. So one of the things that I've noticed during lab time is that students will send me their lab time screenshots, and it will have like 15 compilers in it, right? Which means that you've been working the entire lab time writing code without ever once saving it or compiling it or running it. Your code should always be in a place where your code compiles and you can run it, and you can test it, right? Like you can see when I'm writing code, I write a couple lines of code and I save it, compile it, test it, and then I write a couple more lines of code and I save it, compile it, and test it. Sometimes I'll do something like this where I'm kind of like showing you different ways of doing things, and I'll kind of code for a while. But when I'm actually doing development, I will write something like this, and then I will test it, and make sure that, everything's working right. And so what I'm doing here, by the way, is character defaults to ASCII code 0, and ASCII code 0 doesn't print anything. And so what I'm doing is if the thing's at its default value of 0, it'll put a space out instead. Are you guys familiar with ASCII, ASCII? So the null character doesn't print anything, and it initializes itself to 0. Vectors initialize themselves, arrays do not. So A is 65, B is 66. So A plus 1 is B, A plus 2 is C. You guys with me? What is $sign plus double quote? What is $sign plus double quote? What ASCII value is that? If you add together $sign and double quote, what ASCII value is that? Or just what number is it? Because every letter that you see in those single quotes, is actually just a number. They're just 7-bit integers, technically. Okay, 34 and 36. Yeah, you add them together, you get F, which is 7. So, how you type. So if you want to never be fireable, you could have character C is equal to that, and C plus equals $, and then you can see out C, do not touch, spray. Okay. So this is just printing out capital F with more steps, right? You guys understand? Anytime you have something in single quotes like this, it is literally just giving you a number. It is literally just whatever value double quote has, it just puts that number into C. Whatever value $sign has gets added to it, and so a $sign and a double quote added together is capital F. You guys like that? Is that fun? Does this make you love computer science? You can always count on your company to never be able to fire you if you write code like that. If you typecast C to an int, you'll have it output 70. That is correct. So if you ever want to know what the ASCII value of something is, you can just cast it. Yep, girlfriend not found. There we go, 70. Mm-hmm. Or if you want to do this, the C++ static cast to an integer C, which is the same thing, just with More typing, 70. Okay. So let me show you guys something also kind of important. And that is the notion of auto. Okay, so auto is not just the first name of Otto van Bismarck. Anytime you have a type name that's like really long, like you could have, for example, const vector of chars const iterator as a type name. Oh Lord, that's a long type name. Equals vac dot cbegin or I don't know. Anytime you have a long type name, you can use auto instead. What auto means deduce the type from the right hand side of the equals. Okay, so if I had integer x equals 5, and I change this to say auto x equals 5, this is literally the same as typing int x equals 5. Literally the same thing. When you say auto, this is not like Python. In Python, variables don't really have fixed types. They can change types. It has a dynamic typing system. In C++, every type is fixed. You're like, but this isn't fixed. It is fixed. It's fixed by the right-hand side. It's just a way of avoiding redundancy, okay? And one of the nice things about auto is that here, you're actually repeating yourself, right? Like when before, we were repeating yourself. So when we say a vector of chars like this, what if we came up here and changed this to be a vector of integers instead? Now, this will not compile. Do you guys see this down here? That is no longer a vector of chars. It is now a vector of integers. So you have to repeat yourself. Anytime you have a dependent type, anytime you have a type whose type depends on another type, that's a good time to use auto, okay? There's two uses for auto. One is when a type is really long and you don't want to type it. And the other use for auto is when you have one type that depends upon another variable for its type. Like here, the type of row has to be whatever we typed up here, right there, in the vector events, or chars is what it was before. And so in this case, watch what happens though if we have auto. It just works. And if we change this up here to be a vector of doubles, see that? Also has to change there. Down there, this code here doesn't need to change. Isn't that cool? Auto deduces its type. It figures out what type it's supposed to be from whatever is on the right-hand side. In this case, it's figuring out that it is supposed to be a vector of chars, or in this case, a vector of doubles. Okay. So we go back to a vector of chars, refactor this code here, then this does not need to change. It's cool. Okay, so let's play a game. Let's see if you guys can figure out what type these things are. So what type is Y? Olson. What type is Y? Int. Good. Everybody type int in chat. That's the easy one. All right. The int. All right. What type is Y now? What type is Y now? Let's play a game. What type is Y? It is in fact a double. A lot of people think it's a float. It is not a float. What type is Y now? Still a double. This is a valid double. All right, what type is Y now? Good. It is a float. It is a float. Very good, very good, very good. Pain. It is a float. What type is Y now? It is in fact a long integer, also known as a 64-bit signed integer. What about now? What type is y now? Yes, you are correct. It is a unsigned integer. It's an unsigned integer. What about now? Capital U. No guesses on chat? That's fair. I'm pretty sure that's a 32-bit character, at least according to my TA it is. What about this? What is the type of y? It's a string. This is just a string. Char. Nope. Nope. All of you have gotten it wrong. 100% incorrect. It is not a character array either. The type of y is const character pointer is the type of y. It is a pointer to an address in memory, and it is immutable. You cannot change anything there. So not a string, not a string. If you know, strings, you can do things like you could see out y.size, right? Nope, doesn't exist. Nope. What about if you put an S there? What is that? Compiler, what do you think? Put an S after the double quote. Compiler seems fine with this. That's a string. So if you want to have a string literal that's actually a C++ string, that's how you do it. Okay? So you put an S outside the double quote, and that makes it a string literal, not a C string. A C string is a garbage type. Everybody, yeah. So the way that strings used to work in C. Yeah, everybody hated them. C++ strings are way nicer. So if you want a C++ string, you put a little S after the closed double quote. All right. How about don't use auto? Be careful with auto. In order to use auto, you have to have a certain amount of system mastery, let's say. You know, you might think that you're getting a float when you're getting a double. You might think that you're getting a string when you're not. So it's there's a reason why I'm doing this lecture right now. You know, I'm not saying not to use auto. I'm just kind of running through some of the sharp edges on it. What is the type of y? We know that letters are numbers, right? Integer? Char? Char? Const char? Not a constant. I can modify it. So we got an integer if we did that, but if we do this, yeah, it is not a char, I don't think. At least we're good. Unless we have something up here. No, that's okay. Let's get rid of that. Sorry, I think it is a char then. Okay. Okay, yeah, no, that's correct. Okay, it is a char. Y++ should make it B. Yeah, good. Yeah, it's a char. Y is a char. Okay. A lot of times, though, when you do math with characters, they turn into integers. So you have to like cast them back into characters. So it's one of those things you have to kind of be careful for. But yeah, we're saving the result. But if we do like Y plus 10, then we get 75. Do you see that? We don't get K, right? We get an integer. Because if you, the rule for mixing types when you add things and stuff like that is you get whatever type is wider. And a 4-byte integer, which is what 10 is wider than a 1-byte char. And so when you mix a char and an integer together, you get a integer. You don't get a char. So if you want to turn that back into a letter, you just cast it back into a character like that. And then you get K. Yep. So Y is in fact a char here. Yeah, it's gonna. So do you guys understand? Oh, one more. Auto Z. What type is Z? What is Z? Will this compile? What is Z? Compiler. Can't do it. Okay. You have to, if you're going to deduce the type, you have to have an equal sign. Or it doesn't have a right side. Or in this case, it is deducing the type from vec. So vec is a collection of vectors of characters, and so row is a vector of characters. And then we're saying here, for every column in the row, do something. Okay. So let's do something a little more interesting than tic-tac-toe. Let's have a 20 by 10 grid and delete the old code here. Clean it up a little bit. Shrink it down, getting rid of the options. Make this by reference, and we're not going to make this constant anymore because we're going to be modifying it. So what we're going to do is we are going to fill this 20 by 10 grid with random letters. Okay. So what we're going to do is we're going to make a word search. All right. So we are going to have a 20. What is it? 20 rows or 20 columns? 20 rows. Let's do the opposite. Let's do 10 rows. Let's do 20 columns because that fits the screen a little better. So we're going to have rows. So if we have 10 rows, what is the first row called? What number is that? 0. Good. And the last row is going to be 9. I'm just going to put a ... here because I'm not going to draw 100 boxes for you guys. Sorry. And then we're going to have 20 columns, and the columns go from 0 to what number? We have 20 columns. 20 columns. And they're going to go from 0 to 19. Very good. I'm going to put another ... right here. And there we go. Okay. So what we're going to do is we're just going to fill this with random A, Z, C, D, R, Q, N, O, B, C, U, L, K, O, M, Z, A, Q, R. Okay. So we're just going to fill this entire thing with random letters. And you guys are going to get to write code that will, well, we're going to work on this together. Okay. So how do we, first of all, make a random letter? Okay. It'd be really cool if we had a function, like a standard library function would be really cool, right? Where you just say that guy is equal to random, you know, like letter, right? But unfortunately, it doesn't exist. There's no random letter function. So how do we make a random letter? Now, you guys know that letters are just ASCII codes, right? Like capital A is 65. There's 26 letters in the English language. So how do I randomly roll a letter. You use rand in static cast the chart. Absolutely. So we're going to, of course, do srand time. Actually, let's start off by just a fixed seed, and then maybe we'll mix it up in the future. Okay. So we're going to need a char random letter function, and we're just going to return letter A plus rand modulus 26. Easy as that. Okay. So this is a function. Every time you call the function, you're going to get a random letter out. And it's going to be fixed. We have a seed of 0. So we are going to have the same random word search puzzle every time. If we wanted to, we could ask the user, what seed do you want? And generate a different word search every time we played the game. So here we're going to set that and 1, 2, 3, 4, 5, Y5Y, Shift P, and I could put the printing together. You know what? I'm going to make a function, and this function is called print vec, and it's going to take in a vector of chars named vec. Should I pass it in by call by value, call by reference, or call by const reference? What do you guys think? Should I duplicate my word search every time I pass it in, then throw the duplicate away? Is that wasteful? If I pass it in by reference, do I want my print function to be able to modify the word search, or should I pass it in by const reference? Const reference is correct. So this is going to be const, and that is going to be by reference. Okay. And then I can write a little range-based for loop. In fact, it's pretty much done for me right here. Paste. For every row, for every column in that row, this needs to be a const now. For every row, every character in that row, this doesn't need to be const. For every row, for every column in that row, print it out. See out the value, and we'll put a little space, maybe a tab, maybe space. And then at the end of every row, what should we do? So we're going to print every letter in the row, going left to right. Then when we get to the end of the row, what do we need to see out to make the thing look not stupid? Inblind is correct. It's a very common pattern you'll see, by the way. As you're going across a row, you print everything with like a space or a tab or something in between. And then when you hit the end of the row, inline. If you're doing HTML, if you're echoing HTML to the screen, it looks very similar to this, where you're doing like a table row, then each column, then end table row at the end of it, and then you can have nice formatted, data coming out of your C++ program. Okay. So now we've got a function that can print the vector. That's cool. So print vec, sure, why not? And so this is a function that will print your 2D vector. Do you guys understand what I mean by 2D vector? It's we don't need that anymore. Okay. So vectors are always 1D, but we're making a vector of vectors. So we are making a 2D vector. You might ask, why is there nothing in the standard library to do a matrix? It's coming. It's coming right now. We actually just got mdspan C++ 23. This is a new newness. It's not actually a multi-dimensional array. It just pretends to be one. So what you can do, if you look at the code example, is there a code example? mdspan. Yeah, there is a code example. Okay. So what you can do is you can have a vector that's a 1D. Remember how I said that, like in practice, we typically just use 1D data structures? So you've got a 1D vector holding 12 elements, it looks like. And then mdspan, multidimensional span, doesn't allocate memory, it doesn't own any memory. But what it's doing is it is pretending to be a 2x6 matrix. So you can view this vector as if it was a 2-row, 6-column wide 2x6 array. Or you can represent it as a 2x3x2 array. Vector, whatever you want to say. So it allows you to access it using 2-dimensional coordinates or 3-dimensional coordinates. But it's actually, under the hood, just a 1-dimensional vector as before. So this is a new thing. And so you might not even like have access to this yet because it's still 2023. And unfortunately, compilers lag in support for a lot of things. Maybe it's out, maybe it's not. I haven't even checked yet. But that is the new newness. And unfortunately, I think there is a matrix class coming, maybe, possibly. We'll see how that goes. But it's just unfortunate because like we've had vectors since 1998, and they're fine. The only downside is that is kind of ugly, you know. Like I've seen better. Color grid's easier to work with. It bridges people. Color grid, just give it rows and columns, and it's like boom, here you go. Here's a 2D vector. I don't know why it's so hard. But yeah, there's nothing in the standard library really that is like color grid or something like that, which is unfortunate. And basically every C++ textbook will have a little chapter on like implementing a matrix class, you know, that works like a 2D vector. It should be in the standard. I don't know what to say. So this is kind of gnarly. This is kind of ugly. Sorry, it's kind of the best that we have right now. But this is how you make a 2D array, a 2D vector in this class. Okay, so compile. Boom, there we go. Okay. So, again, every time you write a little bit of code, right? Like a little bit of code, save it, compile it, test it, make sure it looks right. Like, you know, I screw up all the time. You know, I if I forgot the end line there, right? I do that. You're like, oh, look, it's all one line. That's not helpful, right? And so, yeah, I mean, fix it, compile it, run it. During lab time, what I don't want to see is people just like I said, writing 40 lines of code, and it's popping up an error message like you're doing something wrong, and you don't ask. Like, I'm literally sitting here the entire lab section, waiting for you guys to be like, hey, why is this not compiling? And I'm like, well, you know, you got this part backwards, or you forgot the parentheses, or you forgot a semicolon or whatever. You know, you should never not be saving and testing and iterating. Engineering is an iterative process. It really is. You know, whenever you build a product, you always start with something small and you iterate and you grow it. And computer science is no different. You have to work on a little bit at a time. Okay, so now we've got this. Okay, we've got this here. We've got arc up here. Arc by neck. That's cool. Tap. Anyone else see any words up here? Lore. Right here. Sound. Lorem ipsum. Is it in there? That'd be pretty impressive. Zow. Kit. Yeah. So let's write some code to like do a little word search, right? So, but before we do this, let's talk about a couple things. First of all, if we're given a homework assignment, like I don't know, word search, and I'm not gonna enter it. You're given a homework assignment where you have to find every English word within you know the 2D array here. How would you go? What file has every word in the English dictionary in it? Do you guys remember? Grid looks better than the in-person classes grid. Yeah. I made it 20 by 10. Makes it look a little bit better. Do you guys remember what file has every word in the English dictionary in it? It is user share dict words. Okay. So there's a couple different. This is a teachable moment. Okay, so we've got our 2D vector. It's filled with random letters, and now we need to decide how the hell are we going to go through every word in the English dictionary and see if they're within this word search, either left to right, right to left, top to bottom, bottom to top, diagonal this way, backwards this way, backwards. It's like 8 directions that the letters could be in for every word in the English language. What do we do first? Because that's a heck of a task, right? Like there's a lot of things that can be done first. Should we be opening the dictionary file first? Right? And, should we get that working? Should we try getting left to right working first? Should we try getting top to bottom working first? Diagonals working first? Should we just try for one word, getting one word to work first, like pap or arc by neck or something like that? Like, what should we open a dictionary, create a 2D vector from the dictionary, make functions for different directions, all at the same time, all at once? That's all our first step. Make 8 functions. Insert testing is needed. So this is a teachable moment because there's, it's not quite out of our skill level as a CSI 40 student, but it still hurts the brain, right? And this is something that you're going to encounter in computer science a lot, where you're just going to have a situation where your brain's going to hurt. Like you're going to be like, And my advice, start crying. My advice is to find the minimal work, the minimal amount of steps possible to find a word in this word search. Like a word, not all words, not all dictionary words, not all directions, maybe just left to right, one direction, like the band, one word. That start with the smallest, like operational, bit that actually will find a word. Okay, and then work your way from there. If you write all 8 functions at the same time and you have a bug in one of them, you're going to have that same bug in all of them. You're going to have to rewrite them all. Opening up the dictionary and searching through all the words of the dictionary, you can do that and get it ready, but until you have a function that can find a word in the word search, it's not going to, you can't test it, like, sure, you can open the file, but you can't do anything with it yet. So I think, and this is part of the process of computer science, this is actually the essence of computer science. Like maybe the most important part of computer science is taking a problem that has a lot of different pieces to it. You've got left to right and right to left and top to bottom and bottom to top for every word in the English dictionary. There's a lot of things here, and just trying to figure out, cut away top to bottom, cut away bottom to top, cut away the dictionary, and just get down to what is the essence of word search and solve that. Once you can solve that and test it and debug it, then you can, like, if you get it working for left to right, now try getting it working for right to left. It should be very similar. Once you get it working for left to right and right to left, now try top to bottom and bottom to top. It should be very similar, except the rows and the columns are probably going to be reversed, right? And then do diagonals one way, do diagonals the other way, then reverse those. And then once you get all that working, then open up the dictionary and say for every word in the dictionary, call the function, see if it's in there. That's my advice. That's how I would do it. So we're going to need a function, and this function should return true or false if the word is within the vector. So what is my return type? What return type should I put here? And we're going to call this search horizontal const string reference s const vector of chars by reference vec. because we do. Why are we doing it by const reference? Because it would be really weird if our word search erased the word search. You know, find the word and it erases all the characters. Right? It'd be really weird. Yeah, it should be a Boolean, right? It should be a Boolean because we are returning true or false. So we need this now. Now this brings us to another major point, which is: are we going to do top-down coding or bottom-up coding? Top-down coding means you do main first, then you write the function's main needs. To do this, you create what are called stub functions. Here's a stub function. It is a function that returns a value that is plausible for the function. So given the word, arc, is it within the vector, true or false? It will return false every time. It's a fake function, but it's a fake function that is returning a value that is plausible, that is within reason. If you are writing a function to return a random letter and you haven't written it yet, just have it return Q, or R. Don't have it return $, because that's not a letter, right? Have it return some, pick a random number from 1 to 10, 7 every time. So this is a stub. And this is a very important concept because this gets you out of the chicken and egg problem. Because if we're writing main and main is calling search horizontal and search horizontal doesn't exist, it can't compile because the function doesn't exist. And so you're like, okay, well then I can't do main first, I have to do search horizontal first. But then you can't call it because in order to call it, you have to write it in main. And so you have this chicken and egg problem where you have to do both parts at the same time. And then the students end up writing everything all at once, everywhere. They write every function they need all at once without testing it or compiling at once. And then it is a giant disaster of disastrous proportions. Because whenever you write more than 4 or 5 lines of code, you are going to have a bug in there and it is going to kill you. And then you end up getting into debugging hell where you're just not even sure what's happening anymore. When you've written 4 or 5 lines of code and you test something, you know that you're testing those 4 or 5 lines of code that you just wrote because it was working before and now you've just added a little bit and you want to see if it still works. Okay. So what we do is we put in fake functions like this. And now that we've got a fake function, we can call it. So we can say string s equals read. Please enter a word to search for. And then we can call cout bool alpha. Bool alpha prints true or false instead of 1 or 0 for search horizontal. And we are going to pass in the word and the vector. And of course, thank you, Commander of Completion. Very cool. All right. So and now we're done. We can test this. And we're done. We're not done, but the code will compile. Watch. I can save it. I can compile it. I can run it. Give it a word to search for, and it didn't find it. Look at that. Amazing. How accurate is that? Do you guys understand what I mean by the chicken and egg problem? You can't write this line of code until the function exists. And the function can't be called until it's called in main or some other function, right? So you need both done at the same time. Do you guys understand this problem? And so students are like, well, I'll just write all of search horizontal, before I test it, but I can't. Do you understand this problem here? And so by putting in just a fake function, then now I can test it, and what I'm testing is in part, are my types matching up? I'm passing vector here, but if this function up here wasn't taking a vector of chars, but a vector of integers, then it would detect, right? It's like, oh, nope, type mismatch. You're not calling it correctly. No matching function call, right? So by doing this, you can write 4 lines of code, right? 1, 2 lines of code up here. I'm not counting the curly braces a line. 2 lines down here. I wrote 4 lines of code. I saved it. I compiled it. I ran it. Great. And in fact, I could even maybe put a cout statement in here saying cout s is equal to s this, and just make sure the value passed in is correct. which might be useful if we're doing like, let's add a little bit more code. Let's have void uppercase fi, taking a string not by reference because we're changing it. For every character by reference C and S, C is equal to 2 upper C. Okay, compiled fine. Let's pass it in here, and we will say no, we'll do uppercase phi. Yes. So Bob, thank you, commander of completion, very cool. So Bob will turn into Bob. Again, wrote a little bit of code. Let's save it. Let's test it. I'm going to search for Google, and the word that gets passed in is capital Google. Okay. And oh look, it's not in the word search because it's always not in the word search because we haven't written that yet. Do you guys see that? We have a stub in there, and so this allows us to compile our code and test it. If I didn't have that function in there, if I didn't have this in here, then when I tried doing this, it's like, no, it won't compile. So I can't even test my uppercase phi code because it's not going to compile. And so you have to have all of your jigsaw pieces together, you know. And so what gets a lot of students is that for smaller programs, they can do it fine because they can just write the whole program from top to bottom, input two numbers, add them together, output the result, done. No problem. But when it comes to more complicated things like this, where you've got horizontal and vertical and backwards horizontal and backwards vertical, everybody tries writing all of it all at once, and it explodes in complexity. It explodes their brains. Okay, so what we're going to do is just focus on one word, one direction, horizontal in the vector. Okay, so now the fun begins. All right, so now let's actually write it. So if we've got our word search here, what we're going to do is we're going to start for every row, for every column. We're going to go and start at each one of these spots, but not on the rightmost ones. Like if we're searching for car is 3 letters long, right? So we never should start on the right 2, right? Because you can't find car going to the right if you're on the rightmost column, right? Because you can only find the C. The other 2 are going to go off the edge of the boundary. So what we need to do is start not at column 19, but column 18, column 17. So if we have a 3-letter word, we need to move back 2 letters from the right edge. So we need to use a traditional for loop for this. We cannot use a range-based for loop because we're not iterating over the entire thing. So the traditional for loop for looping over a 2D array, I will repeat this for you. So for integer row equals 0, row is less than vector dot size, row plus plus, i2y paste for every column in that row. Now, this is a bug, by the way. Column plus plus. I am going to leave that bug in there. I'm going to leave the bug in there, and we will use this bug as a exercise on how to debug and how to find the mistakes. So, like I said, we need to not go to the edge of the word search. If we have a 3-letter long word, we need to come. We cannot start 1 away from the edge. We cannot start 0 away from the edge. We have to start at least 2 away from the edge to find it. And so we have to subtract out s dot size. So if it's 3, we're subtracting out 3, and then we have to add 1 back in. And this is why it's really useful to actually sketch things out, right? Do you guys understand what I mean? Like if I'm searching for car, you know, I can't start on the last column because there's not enough letters left, right? In order for me to start, I have to have at least 3 letters left to the right to start searching for it. So I have to move back 2, which is the size of the word, plus 1 or minus 1, depending on your perspective. Do you guys get that? Why we would not start on the right edge looking for the word car? If we're searching for pool, 4 letters, then the only, we could we could start here. That's fine because there's enough room. P-O-L-L. We start there. That's fine. P-O-L-L. That's fine. But we can't start here looking for pool because we're going to go off the edge of the matrix, the 2D vector, and we're going to go out of bounds. So thinking about going out of bounds is pretty important. Or you just try going out of bounds, and if you go out of bounds, you just break. Yeah, there's different ways of doing this. I like this way though. Okay. So for every row, for every column, what we're going to do is just say, does that spot match the first letter in S? How about that? So if vec.at_row, remember it's always rows first, then columns. That's convention. That's the convention. You can make it work the other way if you want, but people get salty at you. It's always rows first, then columns. It's always Y, then X, which is backwards from how we do it in algebra. Right? So, yeah, we always do X first in algebra, then Y. In computer science, it's Y, then X. Sorry. So if the point that we're at matches the letter, the first letter at least, S.at0, then we will... What do we want to do here? What do we want to do? Maybe see out a asterisk. And otherwise, we will see out the letter vector.at_row, .at_column, followed by a space. We're going to print the word search again, but every time the first letter matches, we're going to print an asterisk. And so, let's see if this works. We're going to search for world. Remember what I said? What are we missing? What are we missing at the end of the row? I told you, people make these mistakes all the time. What are we missing at the end of the row? We got our whole word search printed out on one line. What are we missing? Do you see that? Okay. Yep. Missing the end line. See out line. And we're going to search for, let's clear the screen. Let's search for world again. And notice that we're not, this is weird, isn't it? Told you it was a bug. This is weird. Why are we not getting the entire 2D vector? The W is in fact getting replaced with an asterisk, but we're not getting anything past spot 6. We're getting all the rows, but we're not getting all of the columns. Why? This is a bug. Why is this not working right? Any ideas? Now, we are, let's do this again with maybe just the letter W. Hey, look, we get more columns this time. But it should be going all the way out to the last one, right? Because if you have a one-letter word, it should be printing the entire word search. But it's not. All the W's are being tagged, but we are not actually looking past a certain point. We should be going all the way to the end. So let's take a look at it again. And this is one of the reasons why when you're developing, print out the string. Like what if we had a mistake in uppercaseify, right? Where, we, I don't know. We accidentally erased the string, right? We could have. And then now when you search for hello, you can see that the string you're getting is empty string. You're like, oh, shoot. So the problem isn't with word search at all. The problem is with, something earlier, right? This is why when you're doing development, the principle is called see out all the things, right? See out all the things. So as you're doing development, just print things as you're going along. and just see if what's happening is actually matching what's in your head. It allows you to trace the flow of your program and see if the program is doing what you think it's doing. Okay, and our program is not. It's not going far enough to the right. So the problem isn't with the rows, because we're getting all the rows. The problem is with this. So what is wrong with that? That's and in the 12 o'clock section, we didn't see out all the things. And when the code was only finding things in the left half of the world and not the right half of the word search, we were mystified. So this time when I'm doing it, I'm just printing out things as we go along, which is good practice, right? And then after it works, you pull the cout statements out. So what is wrong with that code? Is vector.size the number of rows or the number of columns in the world? How do we get the number of rows? How do we get the number of columns? Yes, so vector.size is the number of rows. So what we are doing here is saying the number of rows minus the size of the search plus 1. Are the number of rows and the number of columns the same? Now, if we had a square word search, we probably would have missed this bug. If we had a square word search, it would have hidden this bug. And this is one of the reasons why when I was making these sizes here, I made sure that they were rectangular, that they were not the same size. Because if we had 10 and 10, this would actually work fine. But because rows are 10 and columns are 20, we are taking 10, subtracting off the number of letters, like hello, 5, and that's why it's only going a little bit in. This is wrong. This is the number of rows here. How do we get the number of columns? How do we get the number of columns? Vector.at row.at dot size. Like that. So what is the size of a row? How many elements are in a row? That's the number of columns. So how many elements are in this row? That is the number of columns. Now, if we run this again, and by the way, this was not an immediate fix and an immediate aha moment. This actually took a lot of thinking in the 12 o'clock section to find. But it's easier when you're counting all the things. And so we can see here, W is in fact getting tagged on all these things here. Cool. Now we need to go to the second letter. So what do we need? This code is working for one letter. How do we make it work for every letter? For every letter in the string. What do we have to add inside of this doubly nested for loop to make it work for every letter in the string? Something in the words that I just said there. For every row, for every column, for every letter in the string, see if it matches. How do we do that? So what we're going to do, we have a word search, right? And so the way that the word search is going to work, right, is we're going to start off at row 0, column 0. And if our word is car, at row 0, column 0, if the first letter here is a C, then we're going to check 1 to the right and see if that's an A, and then go 1 to the right. And if that's an R, we're going to return true. If any of those don't match, then we go, okay, let's move on and move to row 0, column 1. Does these 3 letters match? No. Move on. Do these 3 letters match? No. And D, A, and R, close. Yeah. So what we're going to do is say for every row, for every column, for every letter in car, see if 1, 2, 3 of them match. So what do we need to add to our doubly nested for loop to make it work for every letter in the word that we're searching for. Double equals function for a string? I wish. These aren't strings, though. They're just vectors of characters. Now you could rewrite this as a string. Look at the next few letters to the right. So what do I need to add to look a few characters to the right? How many letters do we have? I don't know. 1, 3, 5, 7, 9. Nobody knows. So what do we need? What do we have to add inside of this doubly nested for loop? We need another for loop. The triply nested for loop. How do your brains feel looking at this? All right. So for every int I equals 0, I is less than s dot size, I plus plus for every letter, and we fix the bug now. Okay. So we're saying for every row, for every column, for every letter in the word, see if it matches. Okay. And so since we got it working with one letter, now we can modify this to work with any number of letters by saying that, switching out the 0 with an I, because the first time through the letter I is 0. Next time through, I will be 1. And then we need to move one column to the right every time. First time through, I is 0, so it's just what we had before. Next time through the loop, I is 1. We don't want to see out the things anymore. What we want to do is, if it matches, if we get a match, yeah, I know it's empty, thank you. If we get a match, then we move on. If we don't get a match, break. So if we got a match, we got a match, and we're on the last one. How about that? How about this? Okay. So if we got a match, and if I is equal to s dot size minus 1, if we're on the very last one, we made it. All of them have matched. Then we get a return true from the function. And then if any of them don't match, if we're searching for car, the first one matches, the second one doesn't, we break out of the for loop and we move to the next point. But if we get a match, and this is the last letter that we have found, we have successfully found all of them, that we return true. If any of them don't match, we break. And we can get rid of the cout statement now. And if this doesn't work, then we'll have to put the cout statements back in. But let's see if this works. Dizzy, I know. Should hurt your brain. Hurts my brain. This is not how we did it in the 12 o'clock section either. Okay, so A. Okay, well. True, yes. In fact, A is in there. So let's search for dar. True. Okay, cool. There's dar right there. Let's search for was. Not in there. So it's not searching backwards. So KKY. Search. True. YYX. False. Okay. I think this function is working. Not entirely possible. It's entirely possible it's not, but I think we're good. I think this is a good starting point for you guys now to work on it. So this is another great programming exercise. I am handing you code that works, I think. Sure, let's say it works. If not, it'll be a good debugging exercise for you. So I'm handing you code that works, that can find a word in this word search horizontally left to right only. You guys need to make it work right to left. You guys think you can do that with the working code that I'm giving you? Can you reverse it and make it work in an opposite direction? Modify this code or make a new function? Up to you. It's up to you. Move, copy main.cc into public / 925.23.cc. Let's ignore the error messages here. And so if you guys want a copy of this code, it is under 925.23.cc. Copy that to your current directory. And now you will have a copy of my word search code. So if you happen to be given, oh, I don't know, word search as an assignment in the future, hypothetically speaking, you have got code that is generating random word searches. You know, you could switch it up and not seed it to 0 every time. But you guys need to do this to copy it. And then you will need to do the following. Oops, echo. You will need to do the following. Make it detect words right to left in addition to left to right. Make it find words top to bottom and bottom to top. Make it find words diagonally in all 4 directions. And make it search for all words in the dict file. Okay. Let's see how far you guys can go with this today. So you're given working code that will find things from left to right inside of the word search. Make it work from right to left instead. This is actually a really good skill in computer science. If you find working code that is similar to what you're trying to do, if it's similar code to what you're trying to do, learning how to take it and modify it is really important. And begin. I want to see you guys streaming this. I don't want to see anybody AFK, idling. Start streaming. Start working on this. I want to see your thought process when you're doing this. All right, begin. All right, and we are back. I have been watching you guys coding. Some have just been staring at a blank screen the whole time. It's fine. This isn't Friday. I think I'm going to be a little bit stricter on Fridays. A lot of students have just been like not coming to lab time. And Mincarelli, you know, they know Mincarelli is available to like make it up. So we're probably going to be a little bit stricter on that in the future, or at least just have Mincarelli's lab sessions be harder than the one on Friday. So let's take a look at some code here. You guys did, so starting at row 9, going backwards, starting at column 19, going backwards. Yeah, this is, there's a couple problems with this. First of all, you changed this and you changed the countdown, but the conditional has to change also. So all 3 pieces of the for loop have to change. Think about it. When your row is at 5, are you less than vector.size? Yes. When you're at 4, are you? Yes. When you're at 3, yes. 0, yes. -1, yes. I mean, I guess technically it might underflow to signed unsigned comparison. I don't know. But basically, it might, yeah, you shouldn't rely on underflowing to cause your code to be correct. The bigger issue, maybe that's not the biggest, I don't know. Who knows which one's bigger. But you also have what are called magic numbers in your code. So, and I understand that you said that. Like, I don't know how to get, you know, how to get the number of rows, how to get the number of columns. As it turns out, it's on the comment right above you there. So how to get the number of rows is vector.size. Vector.size is the number of rows in the vector. How to get the number of columns is you get the size, the number of elements of the current row that you're on, which in the case of a rectangular word search will be the same on every one. So you could easily just say vector.at0.size, and that'll tell you the number of columns if you're going to assume they're constant. A magic number is generally considered, and again, I understand you realize this, the problem. You don't want to hard code any number into your code, except maybe 0 or 1 or something like that. Like, you know, if you do something like, say, you know, int x equals 0, that's fine. But you know, if you have like a 19 or a 6 in there or something, like you need, like at a minimum, you need to have a constant, right? Like constant rows equals 10, you know, or some, you know, like if you're going to hard code it, at least give it a name. But really, this is the correct way of doing it. So what you want to do is just say constant rows equals vector.size, and the same for columns. And then you will have, you put in rows here. And then coming back over here, if vector.row column I plus 1. Yeah, this is still going to the right. So every time I increments, it goes one column to the right. What this plus 1 needs to be is minus 1. You need to be going to the left, not to the right on it. If I double equals size minus 1, return true, that's fine. Yeah, so this plus 1 needs to be a minus 1, and then you need to back off the left side of the vector to make sure you don't go out of bounds to the left, versus the code that you have here, which is still backing you off from the right side. The reason why we don't go all the way to the right edge of the word search is because we're gonna, like, if we're searching for cow, we're gonna go this column, this column, this column. We're gonna go 3 total columns. So we have to stop 2 columns back from the edge. Otherwise, we're going to go out of bounds. If you're going the other way, then you have to have, you have to stop 2 away from the left edge instead of from the right edge. Okay, but good attempt after all. And then, okay, we got a different one here. So, so this one is very similar. It's got the same problem with the with it not the code to keep you from going out of bounds to the right doesn't matter anymore because we're going to the left. And so this code is in fact going to the left. You have the column minus I here. So every letter that you check, you're going one to the left, one to the left, one to the left. But this is unfortunately going to go out of bounds every time because you're going to start at column 0. And well, maybe not every time. If you get a match on column 0, then you're going to check column minus 1. And that'll trigger an out of bounds error, and it'll kill your code. So you need to start at I is equal, like if you're at cow, like if you're searching for cow, that's 3 letters. You need to start at column equals 2. Okay, so you can check column 2, column 1, column 0. It's symmetrical, and that's one of the things that I'm trying to get you guys to think about, is that I've given you code for left to right to be right to left. It's symmetrical, and so the bounds checking from the right needs to switch to bounds from the left, pull it in everywhere you're going right. Before with a plus I turns into going to the left with a minus I. But it is only like 2 lines of code that need to change. Like on the previous guy who changed the rows, that didn't matter at all because going top to bottom or bottom to top makes no difference when you're searching left to right, And so what needed to change was the columns starting at 3, or starting at s dot size minus 1, and then going left from there each time. All right, so that is it for today, guys. Thanks for coming out. This was 2D Vectors signing off, and we're going to be learning a brand new data structure on Wednesday that's very exciting. It's my favorite of all times, the hash. See ya. Peace.